Okay, we did these questions in class. 1, 2, 3, 4, and gave you this as homework. We'll first discuss this and then move on. The question says the diagram shows graph of y is equals to x square plus x minus 12. So the diagram is already given, but I can see the coefficient of x square is positive, so that's going to be a smiley face. The graph cuts the x-axis at x0, y-axis at x0 and yk. Write down the value of k. I have the equation and I know that the value of x is 0. So y is equals to 0 square plus 0 minus 12, and that's minus 12 in this case. So I know these coordinates, which are x0 and y negative 12. The graph cuts the x-axis at one point and another point. Find the values of these two. So now the graph is cutting, if it is cutting x-axis, we know at that point y is 0. So if y is 0, I can write 0 is equals to x square plus x minus 12, and we can solve this either by midterm breaking or quadratic formula. Choice is yours. So x square minus 12, I'm thinking of 4 and 3, 4x minus 3x. You need to satisfy both the conditions. When we add these two, I'm getting x. When I multiply these two, I'm getting minus 12x square. So x taken out as common, x plus 4 minus 3 as common, x plus 4 again, x minus 3 times x plus 4 equals to 0. We are looking for the values. So one is x is equals to 3 and the other is x is equals to minus 4. So the positive value comes on this side. This is 3 comma 0, and the negative value is on the left side, that's minus 4 comma 0. So we have the coordinates. Any confusion, please avoid text. You may unmute and speak, because I am on full screen. I won't be able to see your messages. Any confusion in this question? Okay. Then we touched this question in class. The trend would be same. You will be given with an equation, then a table, then graph, and then few parts which would be different from each question. The variable x and y are connected by the equation y is equals to x cube minus 6x. Complete the table of values. So minus 2, we just substitute negative 2 in the given equation and we get 4. Then we substituted 1 in the given equation and you get minus 5. Now you have those points: x minus 2, y4, x minus 1, y5, x0, y0, x1, y minus 5, x2, y minus 4, and x3, y9. In that order. Once they've been plotted, then we draw a smooth curve. I'm going to make one more attempt. The curve right now in front of you is not smooth in this region. It should be smooth on paper with pencil, that is I think this is better than the one before, and this was x3 and y9. Now what does the question say? Use your graph to find two solutions of the equation x cube minus 6x. Sometimes this equation, they're not changing it. See, the equation was x cube minus 6x. It is same, x cube minus 6x equal to 0. Y is equals to x cube minus 6x. So when it is equal to 0, that means y is equal to 0. And my y for this graph is equal to 0 at x0 and at x 2.5. If you are getting 2.4 or 2.6, whatever value you are getting on your graph, you will be writing those. Next part says the least value of y when x is positive. So least value of y in this graph, if I go across the curve, I can see that the lowest point lies here. It is sometimes helpful that you use your ruler and just bring it closer to the curve where it touches and see. For now, I think this is between these 2 points. Now you need to know that these 5 boxes are actually equal to 2, 6 to 8. So divided by 5 is giving me 0.4 each box. Now that's 4, and this midpoint is 5, and I'm writing 5.4. Negative 5.4 is the lowest value for my sketch. And question complete. Any confusion in this particular question? Equation, table, plotting the points, drawing the smooth curve, answering these 2 parts. Next question. The table below is for y is equals to x square minus 4x minus 1. Always same nature, equation, table, graph. Now this time there is one addition. The x's are not given, but the instructions are. So at x minus 2, I need to know what the value of y is. So I'm just substituting negative 2 squared minus 4 into negative 2 minus 1. Negative 2 square is 4 plus 4 2 times is 8 minus 1. 8 for 12 minus 1 is 11. Then it's 6. 6 squared minus 4 into 6 minus 1. 6 square is 36 minus 24 minus 1. 36 minus 24 is 12. 12 minus 1 is again 11. So table done. Then it says use a scale of 2 centimeters to 1 unit. Draw horizontal axis from minus 2 to 6. Using a scale of 2 centimeter 5 units from minus 10 to 15. Now first need to adjust and see where I will get my origin. 2 centimeters to 1 unit and from minus 2 to 6. If this is my minus 2, I'm not actually writing it, and this would be in pencil. I just have to show you, that's why I'm writing what I'm thinking. So this would be my minus 2, and after 2 centimeters, that's 1 unit. So this is my minus 1, this is going to be my 0. Now I've already identified if this is 0, I will have my y-axis along this line. Because this is fulfilling the requirement of question, I'll be able to write values from minus 2 and onwards. Now I've already identified my 0. In case of y, minus 10 to 15, I have to fit these values here in case of y from minus 10 to 15. I'm selecting the lower end. If I start from minus 10 at this point, 2 centimeters are going to represent 5 units. So these are 2 centimeters. When I get up by raising this by value is going to be minus 5, another 2 centimeters is 0. Second 0 is also identified, and I now know where my x-axis will be. Now these are the 2 positions. Just in case if you are worrying that we could just have drawn it in the middle. So if you just draw it in the middle, see, positive side needs 6 units. So this would be 0, this would be 2 centimeters 1 unit, that's 1, that's 2, that's 3, that's 4. So you won't be able to fit in all the values. That is why we first check where our origin should be. So x-axis and y-axis identified where they should be. Now I know my perfect origin. I can place all the values. I'm going for x-axis first. This is minus 2, that's minus 1, this is 0 for both, this is 1, this is 2, this is 3, 4, 5 and 6. In this particular case we've used complete graph. Sometimes it is left over, but in any case it should be covered more than 60%. Y-axis, it says 2 centimeters 5 units from minus 10 to 15. So if that's a 0, this is going to be 5, then that's 10, then that's 15. On the other side, that's negative 5, and negative 10. I'm going to zoom out a bit to see those values. This is x minus 2, y 11. So at minus 2, I'm going to count it. That's 5, that's 10. And I now know that these are 10 small boxes representing 5 units. So one small box is actually 0.5. So this is my 10 and 11 is after 2 small boxes. I got my point. Then at minus 1 we are having 4. Then at 0 it is minus 1, 2 small boxes below that. Then at 1 this is minus 4. Then at 2 that's minus 5. Then at 3 is minus 4. At 4 that's minus 1. At 5 that is 4. And at 6 that is 11 again. Two important things while we were sketching, we can see that this is quadratic equation and coefficient of x square is positive, so you can always expect a smiley face. Other thing, if you made a mistake in these two, you will know when you sketch your graph, because it should be symmetric about the turning point. About the lowest or highest point, it should be symmetric because it is a quadratic curve. So values done. Zooming in again to see those points. I might have to mark them a bit larger in size, but you have to keep it neat, precise and small dots. Now going through the curve, and through these points you have to ensure that the curve is smooth. For that you'll need some written practice on graph page. So that's the curve. Equation given, table done, graph made. Now few parts. Examiner wants to know, by drawing a tangent, estimate the gradient of the curve at x is equals to 3. Now this is x3. This is that point on the curve x is equals to 3. And if you could just see that you will bring your scale closer to it and see, just hypothetically drawing, just see that some distance to right and some distance to left of it, the distance of the ruler must be same and not like this. If I see to the right, that is more. In this case, to the right, that is less. Please excuse the limitations. I'm just using freehand for now. So it should look like this. Once done, you choose 2 good points. When you are using ruler and pencil, draw a long line so you have a great range of selection. See, I think this is one of the point which would be better. X is 5 and y is 1. 5, 1. And on the other side I'm selecting this point, which is x1, and y is 5, that's 6, that's 7, that's 8. So y2 minus y1 over minus 8, sorry, that's minus 8. y2 minus y1 over x2 minus x1. So this is minus 9 minus 4, and 9 divided by 4 is 2.25. And this could have been better. It is like when you are using the scale. If I could show you the limitation, see closely this point. You see this, the line is actually merging with the curve. This should not be the case. This is better. So you will have option to adjust your scale first and then draw the line. I'm keeping it this way for now. find the least. So when y is equal to 4, that is 2 boxes below the point 5. Now for this value of x, when I am to left of it, I can see that y is actually more than that. So he's interested when y is less than that. So that is going to be -1 and above, and the other value in this case is 5 and below. So A is -1 and B is 5. Any confusion in this selection? E part says use your graph to solve the equation x square minus 4x plus 2. Before I do anything, I need to see if this is the same equation or changed. X square minus 4x plus 2. That's x square minus 4x minus 1. See, the equation has been changed. So how am I going to use the same graph for a different equation? This is the thing which I was talking to you the other day, that most of the schools, they tell you to draw this graph again and see where it is equal to 0. You don't have to do that. You just copy the original equation, which is x square minus 4x minus 1. X square minus 4x minus 1. Original equation copied. Then now I'm going to subtract this new equation. This is x square minus 4x plus 2, and when we subtract, we go for change of signs. This was positive, it becomes negative, negative becomes positive, positive becomes negative again. So we are getting rid of x square, getting rid of 4x, and that's -3. So actually you will be drawing y is equal to -3 to find solution for this curve. So y is equals to -3 on the same graph. 2 boxes for 1, in another 2 boxes this is 2, this is 3, this is y is equals to -3. So carefully, this is one point of intersection. Moving along the same line, this is the second intersection. Now I'm going to read these two values. This is 0.5 and this is 3.4. So when we are solving this, that's 0.5 and 3.4, where the curve touches x is equals to y is equals to 0, the x-axis. Remember this thing. The tip is main equation, subtract the question or what is asked, and this is your solution. Or else you will be drawing this complete equation again and then seeing where it crosses the x-axis. Any confusion in these two graphs for now? Okay. Next question. Same thing on repeat. Equation is there, table is there, we have to draw the graph and then few parts. -1.5. I'm using calculator for this question. This is from paper 2, okay? So that's going to be 2 multiplied with the -1.5 cube minus 3 bracket, that's -1.5 square plus 5. So I'm getting -8.5, -8.5. And before I sketch, you see this is cubic graph. This should somehow look like this. Now the other value, none other value is missing. So 4 centimeters to represent 1 unit, draw horizontal axis. So if this is negative 1.5, that's 2, 4 centimeters for 1 unit. This is 4 centimeters 1, another 4 centimeters, that is going to be 0. So I've identified from right hand side, I've identified my y-axis, drawing the line. That is a full page. Y-axis done. Now what do I need is to check for the other range. Minus 10 to 10. 2 centimeter to represent 5 units. So that's simple. Minus 5, minus 10. Two boxes on each side. So minus 10 to 10. If I start from minus 10, this is minus 5, this is 0. So that would be enough space to cover all the given values. X-axis, y-axis, and now we plot the values. And let's write those values first. This is 5, this is 10. 2 centimeters representing 5 units. So after every 2 centimeter, 5 and 10, and this is 15. On the other side, that's minus 5, that's minus 10, and actually from 10 to 10 this is not required. On x-axis, 4 centimeters for 1 unit, these are 4 centimeters, that's 1, another 4 centimeter, that's 2, and on the other side 4 centimeters, that's minus 1, this is negative 0.5, and it was only required till negative 1.5 and complete. Now I can erase this extra stuff. Negative 1.5, y is negative 8.5. So that's 5, 6, 7, 8. That's 9, 8, and this is 8.5. At 1, negative 1, it is 0. At negative 0.5, this is 4. At 0, we have 5. At 0.5, we have 4.5, that's 4. So this is 4.5. At 1, we have 4. At 1.5, this is 5. Going back up again. At 2, this is 9. That's 10. So 2 boxes below. Done with the points. I'm going to zoom in. So I have a cubic curve displayed that ensures that somehow the coordinates are correct. And 8.5, negative 8.5. This is not acceptable. It should be smooth. Done. Equation, table, graph. Done. Now we have few parts to answer. It says use your graph to estimate the gradient of the curve when x is 1.5. Same thing. So when x is 1.5, this is x 1.5. At that point, I need to draw a tangent. Bear with me along with these limitations. This is again touching to right hand side with the curve. I'll make another attempt. With pencil and ruler, that is easy. This is better than before I'm using this. And when you will be doing it, draw a longer line on both sides. So I'm selecting this point, which is x2, and y is, this is 5, 6, 7, 8. 2, 8, and I'm selecting this point, which is 0.75, 0.75, and y is 1. So gradient y2 minus y1 over x2 minus x1. 7 by 1.25. or you may use calculator directly. So 7 divided by 1.25 is 5.6. Next part says, by drawing a suitable line on your graph, find the solution of the equation. Now see that again. Original equation was 2x cube minus 3x square plus 5. 2x cube minus 3x square plus 5. 2x cube minus 3x square plus 5. And see, this is different. There's another way you can do this. If I just add 1 on both sides, this is 2x cube minus 3x square plus 4. If I just add 1 on both sides, I'll be able to make it look like original equation. 2x cube minus 3x square plus 5 is equals to 1. And if this is the original equation, I can write y is equals to 1. So basically we have to draw y is equals to 1. I'm still doing it with the other method of subtraction, because all the time only the constant will not be changing, they also change the variables. So adjusting is difficult and subtraction is easy. So this is the main equation already written, that's the main equation. And now we copy the question, that is 2x cube minus 3x square plus 4, and we have to subtract it. So when you go for subtraction, we go for change of sign, eliminate, and 5 minus 4 is 1. See, you get 1 in both the cases. Now I'm going to draw y is equals to 1. At y is equals to 1, this is that point, and I can see that to right hand side there's no intersection. So just drawing it to left hand side, and I see the intersection is at this very last point. These are 20 boxes. 1 divided by 20. 1 divided by 20, it is 0.05. One small box is, so that is 0.05 less than 1. Which is 0.95 for my sketch. Any confusion in this question? Today we've done 1, that's 2, and that's 3 graphs. I'll stop right here, share this sheet with you, go through the questions and try to draw them by yourself on graph paper.